What's up, everybody? This is Tech G back with another video. And in this video, I'm going to be explaining to you the secure shell protocol in case you have no idea what this thing does. So let's get into it. The secure shell protocol. This is a foundational technology for secure remote access and administration of network systems. It has become a standard tool for IT professionals, developers, and system administrators. And in this video, we're going to talk about the details of SSH or secure shell, exploring its history, how it works, its components, security features, and its various use cases. Exactly what is SSH? So secure shell, this is a cryptographic network protocol used for secure communication over an unsecured network. It provides a secure channel for accessing remote systems, executing commands, transferring files, and tunneling over network services. And SSH, it ensures the confidentiality and integrity of data exchange between the client and the server. So now let's quickly go over some historical context. So SSH was developed by some guy in 1995 whose name I cannot pronounce in response to security concerns associated with earlier protocols like Telnet and RLogin, which transmitted data, including passwords in plain text. And SSH, it was designed to provide a secure alternative, incorporating encryption and strong authentication mechanisms. All right, so exactly how does SSH work? So SSH, it operates on a client-server model where the client initiates a connection to the server, and the protocol uses TCP and typically operates on port 22. And here is the basic workflow for how all of this works. So there is the connection establishment. So the SSH client, it initiates a connection to the SSH server using the server's IP address or host name and port number. And once again, the default port is port 22. Then there's the key exchange. So the client and server, they perform a key exchange to establish a secure session. And this involves generating session keys used for encrypting the communication. After that, we have the authentication part. So the server authenticates the client using various methods such as password-based authentication, public key authentication, or other mechanisms like Kerberos or multi-factor authentication. Then there's secure communication. So once authenticated, the client and server exchange data securely using the encrypted channel. And the client, it can execute commands, transfer files, or tunnel network traffic through this channel. And then there's the session termination. So the session continues until the client logs out or the connection is terminated. And the client and server, they exchange final messages to gracefully close the connection. All right, next, let's quickly go over some SSH commands. So SSH uses a set of commands to manage the connection and interact with the remote server. And some of the common SSH commands include the following. So we have SSH, and this establishes an SSH connection to a remote server. Then we have SCP. This securely copies files between the local and remote systems. You have SFTP. This provides an interactive file transfer session over SSH. You have the SSH keygen, and this generates SSH key pairs for public key authentication. And then you have the SSH agent, and this manages SSH keys and handles the authentication. All right, so moving on, let's talk about some of the components of secure shell. So several key components make up the secure shell protocol and facilitate its operations. And those components are as follows. So you have the SSH client. This is the software application or command line tool that is used to initiate an SSH session. And examples of this include OpenSSH, PuTTY, and various built-in clients in Unix and Linux systems. You have the SSH server, and this is the software application or service that accepts incoming SSH connections and processes commands from remote clients. And examples of this include OpenSSH server and proprietary implementations like Bitvise SSH server. Then we have the SSH keys, and these are cryptographic keys used for authenticating and securing the SSH connection. And these include public and private key pairs that are generated using tools like SSH keygen. And then we have the SSH agent, and this is a program that manages SSH keys and handles authentication, allowing users to authenticate without repeatedly entering passwords. All right, so moving on, let's talk about some of the advantages of Secure Shell. So, Secure Shell, this offers several advantages that make it a preferred choice for secure remote access and communication. And the first advantage is that of security. So, SSH, this provides strong encryption and authentication, ensuring that confidentiality and integrity of data transmitted over the network. It offers versatility. So, SSH supports a wide range of use cases, including remote command execution, file transfer, and secure tunneling over other network services. Then there's cross-platform compatibility. So SSH is available on various platforms, including Unix, Linux, Windows, Mac, ensuring broad compatibility. It offers port forwarding. So SSH allows users to forward ports, enabling secure tunneling of network traffic and accessing services behind firewalls. And then there's public key authentication. So Secure Shell supports public key authentication, which is more secure and convenient than password-based authentication. All right, next, let's talk about some Secure Shell authentication methods. So SSH supports several authentication methods to verify the identity of the client. You have password-based authentication. So this is where the client provides a username and password to authenticate. While it's simple, this method is less secure and susceptible to brute force attacks. There's public key authentication. And this is where the client uses a public and private key pair for authentication, and the server stores the client's public key, and the client proves its identity by signing a challenge with its private key. Then there's host-based authentication, and this is where the client authenticates using its host key, allowing trusted hosts to access the server without individual user authentication. Then there's the Kerberos authentication. So Secure Shell integrates with Kerberos, which is a network authentication protocol to provide single sign-on capabilities. And then there's multi-factor authentication. So SSH can be configured to require multiple forms of authentication, such as a password and a one-time passcode, which enhances security. All right, so let's quickly talk about setting up public key authentication. So the first thing you want to do is generate a key pair. So on the client machine, you want to generate a public and private key pair using the SSH keygen command. Then you want to copy the public key to the server. So you would use the SSH-copy-ID command to copy the public key to the server. Then you want to verify the authentication. So you want to test the connection to ensure that public key authentication actually works. All right, so let's move on to Secure Shell security features. So SSH, this incorporates several security features to protect data and ensure secure communication. So the first feature is obviously that of encryption. So SSH uses strong encryption algorithms like AES to encrypt data transmitted over the network, which prevents eavesdropping. There's integrity, so it ensures data integrity by using cryptographic hash functions like SHA-2 to verify that data has not been altered during transmission. There's forward secrecy. So SSH supports forward secrecy, which ensures that session keys are not compromised, even if long-term keys are compromised in the future. There's compression. So SSH, it can compress data before transmission, which reduces the amount of data sent over the network, which improves performance. And then there's port forwarding. So SSH allows secure tunneling of network traffic, providing encrypted access to services behind firewalls. All right, and let's quickly talk about some of the types of port forwarding. So we have what is called local port forwarding, and this redirects traffic from a local port to a remote server. We have remote port forwarding. This redirects traffic from a remote port to a local server. And then we have what is called dynamic port forwarding, and this uses a SOCKS proxy to dynamically forward traffic through the SSH server. All right, next, let's talk about practical uses of Secure Shell. So SSH is used in various practical scenarios, ranging from remote system administration to secure file transfer. One of those practical use cases is that of remote system administration. So SSH, this allows admins to remotely manage and configure servers, perform software updates, and troubleshoot issues. There's secure file transfer. So it supports secure file transfer using tools like SCP or Secure Copy and SFTP or Secure File Transfer Protocol. There's tunneling and port forwarding. So SSH enables secure tunneling of network traffic, allowing access to services behind firewalls or in private networks. And another use case is that of automated scripts and deployment. So SSH is commonly used in automated scripts for deployment and configuration management, which facilitates DevOps practices. And then there's remote development. So developers that use SSH to access remote development environments, edit code, and run applications securely. All right, next let's talk about SSH in the modern context. So SSH continues to be a vital tool in modern network and system administration, adapting to the evolving landscape of cybersecurity and remote work. And the first context is that of cloud computing. So SSH is widely used to manage cloud-based infrastructure, providing secure access to virtual machines and services. There's DevOps and automation. So SSH plays a crucial role in DevOps workflows, enabling automated deployment, configuration management, and continuous integration, continuous deployment pipelines. You'll find SSH being used in IoT and edge computing. So it is used to securely manage and configure IoT devices and edge computing nodes, ensuring the integrity and security of distributed systems. And then there's remote work. So with the rise of remote work, SSH provides a secure means for employees to access corporate resources and manage remote systems. All right, so moving on, let's talk about enhancing secure shell security. So while SSH is inherently secure, it is essential to follow best practices to enhance its security even further. So the first thing you want to do is disable the root login. And you can do this by preventing direct root login by setting the permit root login no command in the SSH server configuration. Then you want to use strong authentication. So you want to use public key authentication over password-based authentication and implement multi-factor authentication. You also want to restrict access. So you want to limit SSH access to trusted IP addresses using firewall rules and access control lists. You also want to implement strong encryption algorithms. So you want to configure SSH to use strong encryption algorithms and key exchange methods, such as the Advanced Encryption Standard or AES. You also want to regularly update SSH software. So you need to ensure that both the SSH client and server software are up to date with the latest security patches and updates. You want to use tools like Fail to Ban to monitor and automatically block suspicious login attempts and potential brute force attacks. You want to configure the idle timeout. So you want to set an idle timeout to automatically disconnect inactive sessions, which reduces the risk of unauthorized access. And then you want to audit and monitor the SSH. So you want to regularly audit SSH logs and monitor access to detect and respond to unauthorized or suspicious activity promptly. All right, next let's talk about some secure shell alternatives. So while SSH is a versatile and widely used protocol, there are several alternatives and complementary tools that provide similar functionality with different features. The first of that is called MOSH, which stands for Mobile Shell. And this is a remote terminal application that supports intermittent connectivity and provides better performance over high latency networks compared to SSH. Next, we have that of RDP, our Remote Desktop Protocol. And this is a proprietary protocol developed by Microsoft for remote access to Windows desktops and servers, providing a graphical user interface for remote control. And then we have what is called VNC, which stands for Virtual Network Computing. So this is a cross-platform remote access protocol that allows users to control another computer's desktop environment, often used for remote support and troubleshooting. Then there's the VPN, or the virtual private network, and they provide a secure way to access network resources over an encrypted tunnel, complementing SSH for secure remote access. And then we have HTTP and HTTPS, so web-based remote management interfaces use HTTP or HTTPS to provide secure access to system and device configurations through a web browser. All right, next let's talk about the future of secure shell. So as technology continues to evolve, SSH will remain a crucial tool for secure remote access and management. However, its role and implementation may adapt to address emerging challenges and opportunities. So the first is that of the integration with modern technology. So SSH will increasingly integrate with modern technologies such as cloud computing, IoT, and edge computing, providing secure access and management capabilities for distributed systems. There's enhanced security features. So future developments in SSH, this will focus on enhancing security features such as improved key management, stronger encryption algorithms, and advanced authentication methods. There is user experience improvements. So efforts to simplify SSH configuration and management. This will make it more accessible to a broader range of users and organizations. There's scalability. So as the volume of remote connections continue to grow, SSH systems will need to scale efficiently to handle increased loads while maintaining performance and reliability. And then there's automation and orchestration. So SSH will continue to play a vital role in automation and orchestration workflows, enabling efficient and secure management of complex infrastructures. All right, so to wrap all of this up, the Secure Shell Protocol, this is a fundamental component of modern network and system administration, providing secure remote access, command execution, and file transfer capabilities. Its strong encryption and authentication mechanisms ensure the confidentiality and integrity of data that is exchanged over the network, making it an essential tool for IT professionals, developers, and system administrators. Now, understanding SSH involves grasping its basic workflow, commands, components, and security features. And by following best practices and leveraging SSH capabilities, users that can enhance the security and efficiency of their remote access workflows. And as technology continues to evolve, SSH will remain a cornerstone of secure communication, adapting to meet the needs of an ever-changing digital landscape. So whether you're managing cloud infrastructure, automating deployment processes, or ensuring secure remote work, SSH just offers a robust and reliable solution for secure remote access and management.